investments and a little bit about compound interests. And they've got an example here that says if you had $100 and it was paying 2% annual interest compounded annually. So what this means when they say compounded annually, that means they pay you your interest once a year. So after 1 year, you have your $100 plus you get 2% of 100, which 2% of something is always multiplying. Change it to a decimal and multiply. And what's really cool here is if you factor out the 100, then you just get 1.02. So your $100 is getting multiplied by 1.02. And you would have, very exciting, after a year, $102. Then, the next year, you would have your $102, and then you would get 2% of that, again factoring, and your total amount after 2 years would be $100 times 1.02 times squared, which if I took 2% of this, this would be another $2, and then I would also get 2% of the $2, which is like 4 cents. Wow. And you would have, after 2 years, $104.04. So simple interest would say, if you were getting a simple interest of 2%, they would just give you $2 every year. But compound interest, the way that it works, is that you get interest on your interest. Now, in year 2, that interest on the interest amounted to 4 extra cents. Super exciting. So much more money than you had before, but a little bit. But if we were to graph this time after time, you keep multiplying by 1.02. This is an exponential function. Yes, this is super close to 1, but it's still bigger than 1. So it would have the shape of everything that's bigger than 1. You just might be in this section for a very long time where it doesn't look like it's growing. But eventually over time, if you waited long enough, you would get to that part of the exponential graph, and then your money starts increasing quite a bit, quite quickly. This is the power of compound interest. Now, if this same amount, so sometimes they say, like, this was compounded annually, meaning that they pay you interest once a year. You could have something that was compounded semi-annually, where they pay you interest twice a year, or compounded monthly. So if we would look at semi-annually, your $100, they would pay you at 6 months and then 1 year. So what would happen is that if normally they would give you $2 in the whole year, then they would decide at 6 months to give you half of that. So at 6 months, they would give you $1. And then they would say, well, if you started with $101, 2% is $1.02. So normally we would pay you $1.02. But now since it's only 6 months, normally we would pay you $2.02. But since it's only 6 months, we'd cut that in half. So at the end of the year, they would pay you another $1.01. So compounding more often gives you a little bit more money, but not a lot more money. Notice the comparison. This one gave you $102. This one gave you $102.01. We're going to find out, and we'll do a bunch of examples, that the real thing that's going to affect how much money you make or how much money the bank makes off of you is the interest rate. When you're borrowing money, you want that number to be as low as possible. When you are making an investment, you want that number to be as high as possible. The compounding periods does have an effect, but not huge compared to the interest rate. So our compound interest formula, and They have it here. Sometimes on the old formula sheet, it looked like this. And what's neat about, what sounds scary at first, is that formula is not on your formula sheet. So that sounds scary because it seems like you need to memorize it, but the answer is no. They decided there are too many formulas they would like to use, so they decided not to give you any of them. But on the exam, whichever formula that you need for one of these questions, they give it to you on the exam with everything explained. So you don't have to memorize any formulas, but they would say, oh, here's the formula. The principal, A0, so A0 is the amount you started with, interest rate of I, and they would even tell you that I should be a decimal on the exam. With the compounding and compounding periods per year, this is how much money you would have. Okay, so whichever formulas you'll need, they will give them to you and explain it. Yes?
What's that little zero between the A and the bracket?
Sometimes we use a zero. This is one thing. But sometimes we use a zero to say at starting point. Like, what did you have at the beginning?
Oh, you
So,
mean like
the principal A0 just means this is the amount you had at time 0.
X0 for like when we have the graph.
Yeah.
Okay.
So it's just a notation thing to say it like a starting point. So let's go to example 3. Put my pen down. A principal of $1,500 is invested at 4% annual interest, compounded quarterly. And so again, they would give you this formula, and they would tell you what each of the things stood for. Question?
Since the exam would be giving us the formulas on the start of them, will you also give us the formulas?
Yes, on your test, I put all the formulas on the questions that we need. So, just kind of nice. You don't have to figure out which formula you need to use. They give you the one formula, and you know that's the one you're going to have to use. So in this case, they tell us the principal. That would go in for the P, 1,500. An interest rate of 4%. So we would have 0.04 for the interest rate. Compounded quarterly. Quarterly is 4 times a year. So that would have a 4 there and a 4 there. And then it says to the nearest quarter of a year, so we're solving for T. When will the amount be 2,500? Okay. This is, at this moment, and later on too, will be a calculator question. At this moment, though, we cannot solve this algebraically because we don't know how. If you could solve this without a calculator, you would have to see these numbers on your powers chart. This is 1.01. Is 1.01 on your powers chart anywhere? No. So the best that we can do right now is use technology, either your graphing calculator or Desmos. Put one equation into y1. If I put the 2,500 into y1, and I put the 1,500, 1 plus 0.04 divided by 4 to the exponent of 4, and there's no t, so I'll just use an x. Now, I have the math type. If you have an older calculator that doesn't do this, you'll need to make sure that you put the 4x in brackets. Otherwise, your calculator will just have the 4 in the exponent and not the x. Now we're going to graph this, and probably if I hit graph, I won't see much of anything. Oh, I do see a little bit. But we'll want to set up our window. Okay? So there are sometimes things that you can do, like sometimes people like to try zoomed fit. Does that turn out now? What turns out really nice? Because we want to find out where these intersect. That looks pretty obvious that they're intersecting. But other times, you can analyze certain things. Like Y1 is 2,500. That is a straight horizontal line at 2,500. Does it make sense that on your window, if I hit my window button here, I for sure want my numbers to be in between, so $2,500 is in between there. Otherwise, I won't be able to see that line. My X-min goes from -1 to 30. That worked out nicely. Sometimes you have to adjust your window afterwards. So we can go second, calculate. Where do these intersect? Number 5. Enter on the first curve, enter on the second curve, enter what it says guess. And 12.83 is X, and it's set to round to the nearest quarter of a year. So I'm just gonna write out all the number right now. To the nearest quarter of a year, when will the amount be 2,500? So rounding to the nearest quarter would be 12.75. But some would argue that at 12.75, can you see that it would be less than 2,500? Okay? At 13, it would be over 2,500. At 12.75, it would be less than 2,500. So in questions like this, sometimes you'll see a final exam actually accept both answers. Because the closest rounding was 12.75. But at 12.75, you haven't quite reached 2,500 yet. So then some would argue that 13 is a better answer. Yes.
Would it be smart to write both? Or no?
And that's why it's sometimes, yes, it's smart to write both. Like, that's why I'd write the actual answer out with all the decimals before I rounded. And then to the nearest points, I might write, to the nearest 0.75, the answer is 12.75. But then it's not at 1,200 yet, 2,500 yet. If I wanted 2,500, I'd have to round up to 13. And if you had a sentence like that, I think it'd be very hard to find a math teacher that goes, okay, they understand what's going on. We're not going to go to the letter of the, what was the official rounding rule in this situation. Okay, questions for practice on this one? 12 and 13.